Hey guys, so welcome. This is our first video lesson as well as our first lesson. We are going to talk about our introduction to equations. I am excited. So if you are tuning in just to get a little review of the lesson, or you're tuning in from home because you weren't here, we missed you if you weren't here. So let's get started. So the first thing that we're going to talk about is order of operations. We all know what the order of operations are. We know that the order of operations are an agreed upon set of rules to perform mathematical operations. So like adding, subtracting, multiply, divide. Okay? The most common way that we know of order of operations is through the saying PEMDAS. So let's take a look. PEMDAS. We have P, E, M, D, A, S. The P stands for parentheses. E stands for exponent. M stands for multiply or multiplication. D stands for division. A stands for addition. And S for subtraction. One important thing to note about parentheses and exponents are that we do those two first. We do parentheses first, then exponents. But multiplication, we do it from left to right. Same with addition or subtraction, whichever one comes first from left to right. Alright. Now let's briefly talk about simplifying expressions. So one thing I think you should know is that expressions can be both numerical and algebraic. If you have a numerical one, that's going to be like 2 plus 2 is an expression. Its answer is 4, but 2 plus 2 itself is an expression. Or your algebraic ones would be x plus 4. That's an expression. The most common way to simplify expressions is by combining like terms. So let's talk about that. Just a few rules when it comes to combining like terms. We do constants with constants, constants being just our numbers, the ones that don't have variables. And we do variable with a variable. So we put the x's together. We can do x plus x, but we can't do x plus 1. So, big deal, big deal, big deal. No constant with variable. So now let's practice a little bit with that, okay? So we have 9 minus 12 divided by 3. Well, first things first, we're going to work with the division, because division comes first in our PEMDAS. So here's our division. 12 divided by 3 is 4. Bring down the minus, have your 9. Now we have 9 minus 4, so we can easily see that that is equal to 5. look at our next one. We have 5 times, in parentheses, 13 minus 7 divided by 2. So first things first, parentheses is our first one. So we keep our 5 times 13 minus 7 is 6 divided by 2. Now we have multiplication and division. So we're going to do from left to right. So this is our first one. 5 times 6, which is 30 divided by 2, which leads us to get 15. Alright, let's look at our last PEMDAS practice there. We got a big one there, lots of stuff. We've got exponents and everything. But first things first, we look at what is in parentheses. Well, inside of our parentheses, we have 6 squared minus 4 times 3. So now within our parentheses, we have to do our exponents first. So we keep our parentheses, and we have 6 squared is 36 minus 4 times 3, all of that divided by 2 times 6 minus 4. Now we still have to do with our parentheses, so we're going to have 4 times 3 inside of the parentheses is what we have to do with. So parentheses 36 minus 12. Now keep your divided by 2 times 6 minus 4. Now, 36 minus 12 is what we deal with first, because we're still trying to get rid of that parentheses. We get 24 divided by 2 times 6 minus 4. Now, what do? Well, remember, we say division and multiplication from left to right. So first we do 24 divided by 2, which is 12. Then we keep our times 6 minus 4. Because I'm running out of room, I'm going to move it up here. Alright, so next we do our 12 times 6. 12 times 6 is 72. So we do 72 minus 4. And when we finally finish that out, we get 68. So, that was just some quick practice of how to do our PEMDAS. Now, let's look at some like terms. Remember, in order to be the like terms, they have to have the same variable and the same exponent. So notice we have non-x and 2x. Non-x and 2x are like terms because they both have the x's. So think of this as, if I have non-x's and you give me 2 more x's, how many do I have? Well, in this case, you would have 11 x's. Okay. Let's look at the next one. Well, I have 3p minus 5q plus 4q minus 1. Well, 3p. So we can't mix p and q. Mixing p and q would be like saying if I have 3 pickles and you give me 5 quilts, then now I have 7 quilts. We cannot combine quilts and pickles. So, what we want to do is, well, we only have 3p. However, notice, we have negative 5 quilts and 4 quilts. So if I owe you 5 Qs, and I give you 4 Qs, I only owe you 1 Q. And then there are no other numbers, so we just keep our minus 1. Okay, let's look at our final one there before we start talking about equations, one of my favorites. So notice, we have 3x squared, and our other like term, negative 10x squared. So 3 minus 10 is negative 7. So we have negative 7x squared. Okay, now we have negative 8x squared. Or not x squared, sorry, negative 8x. It can combine with 7x. So negative 8x plus 7x is negative x. However, our 1 doesn't have any other constants to have, so we just keep plus 1. So that was a brief review on how to use the order of operations and how to work through combining like terms. Now let's talk about what an equation is. An equation is a statement. that values two expressions as equal. So remember, we know what expressions are. They're just statements. So for example, let's look at the first example. 2 plus 2 is the first expression. Is equal to 4, which is your second expression. Two expressions that are valued as equal. So 2 plus 2 is equal to 4. Well, let's look at another example, one that isn't numerical, one that has more algebra involved. So how about 2x plus 1 is equal to 4? Well, then this is your expression 1. I'm going to put x1, and this is your expression 2. You are just saying that this statement, 2x plus 1, whatever x is equal to 4. You are making an equation. And finally, one that you'll see more often here in a little bit, we could say 3x is equal to 2x minus 4. This is the first expression. This is the second expression. And we're just saying that whatever x is, it has to make both of those statements, those expressions, true. Okay? Alrighty. So what we can do, in order to start solving equations, because you knew we had to get there, right? We had to start solving. We've got to understand the properties. So let's talk about these mathematical properties. You've seen multiple of them before. There's addition, there's multiplication, and we're going to talk about examples of each. So let's start by going through the addition. The commutative property of addition is, if we have a number a plus a number b, then we have the same thing if we do b plus a. So what's an example of that? Well, let's just try to pick two numbers and see it. If I do 2 plus 3, it's the same thing as 3 plus 2. Is that true? What's 2 plus 3? 5. What's 3 plus 2? 5. They do in fact work. So this is saying that it doesn't matter what two numbers, which order you put your addition or subtraction, your addition, it's going to work. Subtraction does not work like that. Okay, what about the associative property? Well, the associative property of addition is a plus b plus c in parentheses is going to be the exact same thing as if you do move your parentheses. A plus b plus c. Well, let's try it and see. Let's do a 2 plus 3 plus 1. And let's see if it's the same thing as 2 plus 3 in parentheses plus 1. Well, let's see what we get. If we do 3 plus 1 first, we get 4 plus 2 is 6. If we do 2 plus 3 first, we get 5 plus 1 is 6. So it is in fact true. The distributive property is a little different. It's going to mix addition and multiplication. So we're going to come back to it. How about the identity? When you think of an identity, it means yourself. You think of something that makes you yourself. So if we have any number and we add 0 to that number, we're going to get that same number. You guys knew that already. So if we have 7 and we add 0, it's going to just give us 7. The inverse one. So the inverse means that any number that we have, if we add its inverse, negative a, we're going to get 0. So let's check that out. If I have 2 and I add negative 2, I get 0. Alrighty. So those are our mathematical properties for that. Now, let's talk about them for multiplication. for multiplication. If you think commutative means a plus b is equal to b plus a, then you would be absolutely right to assume that if we have a times b, it's the same thing as b times a. So if we do 2 times 3, we get 6. If we do 3 times 2, we also get 6. Okay, your commutative property is also extremely similar. So if we do A times B times C, then it's the same thing as A times B times C. Let's try this out. Let's do 2 times 3 times 4 equals, and let's do 2 times 3 times 4. So first things first, we would do 12 times 2, which would give us a 24. Here, we would do 2 times 3 first, which would give us 6 times 4, which is 24. So in fact, that is correctamundo. All right. Again, we'll come back to that distributive property. No worries. We will be his friend. The identity. So we want a number we can multiply by any number to get itself. Well, that's 1. A, any number times 1 is going to give you A. So an example of that would be 3 times 1 is equal to 3. Now, in the multiplication world, the inverse of a number, A, is 1 over that number, which will give you a 1. We don't want 0 in the multiplication world. We want 1 as our number. So A times 1 over A gives us 1. Let's try it. 2 times 1 over 2 gives us 1. So that works. Alrighty. So last but certainly not least, we have the distributive property. If we have A times B plus C, then that's the same as saying AB plus AC. How you have usually seen this is a number on the outside of the parentheses needs to be distributed to each place. Let's practice. Let's do an example here. 3 times 2 plus 1. Well, then we do 3 times 2 is 6. And 3 times 1 is 1. And we get 7. So notice 3 times 2, that's A times B. 3 times 1, that's A times C. It is in fact 7. So the distributive property just tells you that we can just multiply A by both of them, and it'll work as well. And that will really help us when we're dealing with expressions that have x's, so that we can break this down and expand our problems. All right. We went through all those so that we could go through the properties of equality, the big deal of this whole entire lesson. So, we've got a couple of these. The first is the symmetric property of equality. So, if A equals B, so A and B are the exact same thing, then it can also be said that B equals A. So, if we say that 3 plus 2 is equal to 5, then we also say that 2 plus 3 is equal to 5. So we can say 3 plus 2 equals 5, or 5 equals 3 plus 2. Either way works. A equals B. 3 plus 2 equals 5. 5 equals 3 plus 2. We can say it either way. So if you get your final answer as x equals 1, or if you get your answer as 1 equals x, both of those are the same thing. All right, addition. If A equals B, then A plus C is equal to B plus C. So let's say we have 3 equals 3, right? Well then, if we add the same number to both sides, then it'll be the same thing. So let's say 3 plus 2. And if we add 2 over here, then we should get 5 equals 5. So all this is saying is, if A and B are equal to each other, if 3 equals 3, then if we add 2 to both sides, it's still going to be equal, because we're adding 2 to both sides. Okay. If A equals B, then A minus C is equal to B minus C. So we have 3 equals 3, and we decide to subtract 2, and subtract 2 on both sides, then we get 1 equals 1. As long as we subtract 2 on both sides, it remains equal. Okay, multiplication. If A equals B, then AC is equal to BC. So what happens here? If we have 3 is equal to 3, if I decide to multiply 2 on this side and multiply 2 on that side, then we get 6 is equal to 6. As long as we multiply on one side and we multiply on the other side the same number, then it is still considered equal. That's the multiplication property of equality. Okay, division. Bet you guys can guess. If A equals B, then A divided by C is equal to B divided by C. So this time, let's change it up. We have 3 is equal to 3. If we divide by 3 on each side, we get 1 is equal to 1, as long as we are dividing by the same number on both sides. Alright, and finally, if A is equal to B, that's our common thread here, then B can replace A in any expression. For this one, I want to give you more of an example in an algebraic form. If x equals 1, so A is x and B is 1. We say that those are equal, x equals 1. Then if we have 2x plus 1, then we can do 2 times 1 plus 1. So you get 2 plus 1, which would give us 3. Oh, I'm so sorry if y'all could not see that. So let me review that real quick. If A equals B, then B can replace A in any expression. So x equals 1, so x is A, and B is 1. We can plug 1 in for x and be able to solve. This is what we do when we evaluate expressions, as you've done before. Alright, so we did all those properties of equality so that I could teach you the golden rule of algebra. What you do on to one side of the equation, you must do on to the other side. You have heard this before. What you do to one side, you must do to the other. Why is this true? What do the properties of equality have to do with the golden rule of algebra? Well, look at the properties of equality. It's saying, okay, if you add the same thing to each side, then they stay equal. If you subtract the same thing to each side, then they stay equal. If you multiply the same thing to each side, they stay equal. If you divide the same thing to each side, they stay equal. So, what you do to one side, you must do to the other side. The properties of equality are what makes this rule true. So, you've always heard it said, but the properties of equality make this rule true. Okay? Alright, so the last thing we're going to do in our video, I know it's getting a little long, is we are going to review how we can determine what properties of equalities happen. So notice here. first you wrote the equation, because it gives us, what is the solution of this equation? You wrote it down. Always, first step is rewrite the equation. Second, they distributed. So let's take a look at what they did there. Well, they decided to distribute the 4. -4 times x, -4 times -6. So they use the distributive property. Okay. That is the distributive property. Then what did they do? Well, notice they found that 8x and -4x are like terms. So they combined like terms. Okay. Afterwards, they decided to subtract 32 from each side. Deciding to do that tells us that we are using the property of equality of subtraction. Because subtraction property of equality says if you subtract from one side, you subtract from the other, then they're still equal. Notice, we took 32 here away, we took it here away. So we can still say those are equal. Finally, divide both sides by 4. So, look, we divided 4 here. And I'm going to go ahead and draw it to show you. And divided 4 here. The division property of equality tells us that we can do that. So then we get our final answer to be x is equal to 3. So, the properties of equality are why you can do what you do to one side, you do to the other. You've been doing this a whole long time, you just didn't know that. That's why. So now let's look down here. And then I promise I'll leave you alone. I won't spend too much time on here. So look at what they're doing. Well, first things first, we're n equals 4 is the solution of the equation. 16 equals 3n plus 4. We're going to identify and justify each step. Well, the first thing they did was they rewrote the equation. First, rewrite the equation. Okay. Well, how do we justify that? Well, there's nothing to justify. It's just the original equation. Okay, now they plugged in 4. So they, second, substitute. I'm going to put sub 4 for n. Well, they plugged in 4 for n. Okay, cool. What makes them be able to do this? That would be your substitution property of equality. I'm going to write prop of equal. Okay? Your substitution property of equality says, well, if n is equal to 4, and you've got an n here, you can plug it in. Okay? So then, they just simplified it. They did 3 times 4 is 12 plus 4, which is 16. So, they simplified. And over here, you can just write simplify, because there really is no explanation besides just using order of operations. You may even be able to put PEMDAS. Okay? And finally, they answered our question. Yes! It is a solution to the equation. So we write a big yes here, and we say state the reason we did this was we just stated the question. We stated the answer to a question in a sentence. Whenever we are working with word problems, we should state the answer to the question in a sentence. Alrighty. So, that's all I have for you. There is going to be a problem that I'm going to have you work on with this. But it's going to be a little worksheet that's got a little bit to go to it. If you are absent, I will give you, this will be in the makeup bin for you tomorrow. If you are here, hopefully reviewing this helps you understand the assignment. Alright guys, y'all have a great day. I promise you I would try not to go over 30 minutes, so I think I did okay. Bye!